Another thing we will need to know is what is the subnetwork that we are in. I give examples here with two LANs, and now if A talks to B, there are two possible cases. If B is in the same LAN, I can send it directly to B by knowing the MAC address of B, and the Ethernet switch or the Wi-Fi will broadcast it to that machine that will receive it. But if it is not in the LAN, that will not work. I need to send it to the router. So I need to know whether a destination IP address is in the same LAN as me. This is how IP works. Any IP system needs to be able to decide it. In fact, the IP algorithm, we will discover in detail a bit later. I'm giving some forward highlight here. The IP algorithm does exactly this. When I have a destination IP address, the first thing I see is it in the same LAN as me? If so, I send it by finding the MAC address of the destination. Otherwise, I need to go to my routing information, and hopefully I have a default gateway or something like this that I will send it to. How do I know if a destination system is in the same LAN as me? Well, by analyzing the network prefix. Every IP machine must have an IP address, plus it must know out of the bits of the IP address, what are the bits that constitute the network prefix, which is also called the subnet prefix. LAN and subnet is the same. Subnet is what IP views, LAN is what physically we view here. They are synonyms for us here. In order to know the subnet, we need to configure the number of bits, because this is not a standard. For example, at EPFL, for IPv4, the subnet prefix is 24 bits. The IPv4 address is 32 bits, 4 words of 8 bits each. So the prefix at EPFL is the first 3 words here. So, for example, 128.178.71, I know that this is the prefix here. And you can observe here that all addresses on these diagrams that are on the same LAN here, they coincide. Their third word here is the same here. So the prefix is made of 24 bits. Right? If we would do this today, and you have to express the fact that the prefix length is 24 bits, then you would put a box somewhere in the configuration saying prefix length equal 24. Unfortunately, this is done using historically, this is not the way it was done. They used a much more clumsy way, which is called a network mask. So instead of saying that the prefix is 24 bits, you will say the mask is 255 3 times .0 here, which is a very cumbersome way, a hacker's way, if you want, of saying 24, because if you write this in binary, you obtain this. Right? You obtain a long string of ones. 255 is a word of 8 bits equal to 1. So 3 times 8 bits equal to 1 gives 24. So a mask is often used in IPv4, practically always, practically never with IPv6, as a way to indicate the length of the prefix. So in IPv6, we would typically say /64, for example, to mean the first 64 bits of this long representation here. We could say it with /24, but for historical reason, and since people don't understand why they do things, most people repeat the old complicated stuff, and they will say that instead. So you will have to work with that. We'll come back to that. Sometimes we need a calculator, a programmer's calculator to map the ones to the zeros. In particular, if you have weird things like our ETH colleagues found it necessary or smart to use 26 bits, right? As long as the prefix is a multiple of 8 bits, things are very simple. When it's 26, of course, it's much more complicated here, right? So the mask will be some very weird thing here.